This video will present solutions to the VCE 2019 Mathematical Methods Written Examination 2, Section B, Question 4. Question 4, Part A. This question is all about a particular species of butterfly. The mean lifespan of this butterfly can be found using the formula for the mean of a continuous random variable, which is the definite integral from 0 to 5 of x times f of x. Part B. The number of butterflies out of 80 that can be expected to live longer than 2 weeks can be found by calculating NP, where N is 80 and P is the probability that a single butterfly lives between 3 and 5 weeks. This is equal to 80 times the definite integral from 2 to 5 of f of x. So, we expect 73 out of 80 butterflies to live this long. Part C. This conditional probability is equal to the probability of living from 4 to 5 weeks divided by the probability of living from 2 to 5 weeks. Part D. The focus of this question now moves to the butterfly's wingspan, which can be modelled by a normal distribution. The probability of a butterfly having a wingspan between 16 and 18 centimetres can be found by using a normal distribution with the mean of 14.1 centimetres and a standard deviation of 2.1 centimetres. The required computation can be done using the norm CDF function, which is found under Distribution in the ClassPad's menu structure. Inputting the values provided, this computation returns a probability of 0.1512 to 4 decimal places. Part E. The cutoff for the smallest 5% of butterfly wingspans can be computed using an inverse normal command, which is found under Distribution Inverse in the ClassPad's main menu. Ensuring that we are calculating the cutoff for the left tail of the distribution and entering the 5% probability as well as the population parameters gives a cutoff of 10.6 centimetres, correct to 1 decimal place. Part F, Part 1. The number of very large butterflies out of a random sample of 36 can be modelled by y, a discrete random variable, using the probability value provided. The probability that y is 3 or more can be calculated on a ClassPad using the binomial CDF command. Part F, Part 2. To find the smallest value of n, such that the probability of n or more very large butterflies out of 36 is less than 0.01, a trial and error approach is one way of proceeding. Using the previous computation as a starting point, we can quickly calculate the probability of 5 or more very large butterflies out of 36. This probability is around 3%, close to 1%, suggesting that we should next compute the probability of n equals 6. As this value exceeds 0.01, we need to consider n equals 7. Based on the evidence gathered by this trial and error process, we can conclude that the smallest value of n that satisfies the less than 1% threshold is n equals 7. If this question were posed in such a way as to make a trial and error process too time-consuming, we could generate a table of probabilities for all values of n using the ClassPad's Graph and Table app. This can be made easier if we copy and paste the syntax of our binomial CDF computation. Change the n value to x and press execute. To compute probabilities for the range of values required, edit the table range to start at 0 and end at 36. Leave the step as 1. Tap the table icon to generate the table of probabilities. As we arrow down, we can see the probability drops below the 1% threshold when n equals 7 or more. Part F, Part 3. The expected value of p hat is equal to the population parameter and hence equals 0.0527. The standard deviation of p hat is equal to the square root of p by 1 take p over n. Part F, Part 4. The distribution of p hat looks something like this. The cutoffs for p hat within plus or minus 1 standard deviation of the expected value are 0.0527 plus or minus 0.0372. The y values that are equivalent to these p hat values can be found by multiplying them by 36. Based on these cutoffs, the probability that the sample proportion is within 1 standard deviation of 0.0527 is equivalent to the probability that y is between 1 and 3 inclusive, as y is a discrete random variable. This probability can be calculated by modifying the cumulative binomial calculation performed earlier. Part G. To determine the size of the sample used to calculate this confidence interval, we can first average the lower and upper bounds to find the p-value. We can now write down an equation for the width of the confidence interval in terms of n. This equation can be entered into our class pad and solved for n. This solution indicates that the sample size was n equals 200.